Good afternoon, friends. So we begin this session on advanced heart failure. We have three talks in this session, and we have esteemed chairpersons over here. But particular to this topic, before I begin, I would like to announce that we have one more guy particular to this field, Dr. C.S. Butch, and who calls himself as a computer savvy Butch. And then there are various combinations of CS which he would deliver while asking questions to us. And I'm pleased that he's there in the audience today, because while we were preparing this talk, we didn't know that he would be in India. Otherwise, you would have been the chosen chairperson for this session. So I take this privilege to talk on artificial tools to predict heart failure. I have already delivered this talk in Varanasi, and this is the second time I'm deliberating the talk in Vadodara today. And why AI is important? Because AI is really coming in a big way. What I am talking today might change tomorrow in terms of thought processes. So we all know that heart failure remains a significant challenge in cardiology, with growing emphasis on leveraging artificial intelligence to enhance prediction, diagnosis, and management. The AI tools are very diverse and tailored to provide nuances, insights for the cardiologist. These tools are specifically tailored to monitor, analyze, and predict heart failure by leveraging data from various sources like implantable devices, which patients already have worn, heart failure patients, and we collect their data, wearable sensors, and diagnostic tests. And they aim to improve early detection, risk stratification, and management of heart failure patients, ultimately leading to better outcomes and quality of life. So in terms of heart failure, how does artificial intelligence help? It helps in AI-aided diagnosis. For example, till now we didn't know that what might be the one thing that correlates as an early heart failure. So we put lakhs and lakhs of EMR data, which is there with insurance companies or other agencies, and then we get an algorithm base that go and follow this manner, and then you can help your patients to detect early heart failure. In terms of monitoring and management by devices, estimation of disease severity, phenomapping patients with heart failure with preserved ejection fraction, prediction of risk of incident heart failure, and predicting the response to therapies. So the first time when that a patient should go and check with his nurse abroad or with his doctor or GP in India, AI will definitely help us to guide the patients directly. In further talk, I can also explain to you that how we can make a whole ecosystem about helping the patients to detect early heart failure. So what are the current gaps and need in heart failure management? Its tailored medicine is not available. There is still lack of a truly personalized approach to treatment, taking into account individual factors such as genetics, lifestyle, and disease history. Early detection is usually not possible in our country. Remote monitoring is still a dream for majority of our country. Predictive modeling to support decision making and improve patient management strategies is advisable to improve the prediction of heart failure progression. Patient in NYHA class 1 or 2 or heart failure class A and B may rapidly go on to class C, but he can be detected early by using AI tools. And most important is integration of data. So methods to integrate, analyze large amounts of data from various sources, including electronic health records, imaging, lab results, wearable devices to support the diagnosis and management of heart failure, is the concern for future. And I think we as an industry, healthcare industry, should gear up for it. Bit of technical topic, how AI works. So AI works by predictive analysis. The algorithms are derived by using AI methods. Imaging analysis. For example, there is a patient of amyloidosis, and me and VC sir have put a diagnosis of diastolic dysfunction. But AI, with help of imaging, because lakhs and lakhs of images are given to that machine, even your echo machines will give out the diagnosis that this diastolic dysfunction is amyloidosis. This is the future of how imaging will work. Wearable technology devices are equipped with AI algorithms to continuously monitor physiological parameters, allowing for early detection of heart failure. Even in the current time, we do have pacemakers, we do have CRT devices which will give a vibratory alert to the patient that your fluid levels are rising, go and see your doctor before you land up in acute decompensated heart failure. Sorry. Clinical decision support systems. This is one of the most integral parts of AI. So CDSS integrates patient data with medical knowledge to assist cardiologists in making evidence-based decisions. In fact, I think the future of classifications also, right now we see ACC, classifications and 100 authors over there. I think future might be just 1 or 2 authors. AI will prepare us to make the guidelines because it has previous data, it has recent trials, and it has latest guidelines. Only thing is to integrate it with the help of the machine. Remote modeling and telemedicine. This is the gist to give home care deliverability of healthcare to the patients. And risk stratification and treatment optimization. So now is the time to increase Lasix, now is the time to remove Zytonix. We can actually put in patient data and we can get outcome summaries. So the existing approach in AI is expert-driven knowledge acquisition, use of machine, particularly the CDSS models, and then we get a shareable knowledge base. The proposed mechanisms are upon expert-driven knowledge acquisition, we put in data-driven knowledge acquisition, so data from lakhs and lakhs of records along with the expert knowledge, and we get a hybrid knowledge model out of this. So the various models are machine learning models, deep learning models, predictive analytics softwares, clinical decision support system, mobile health applications, and genetic algorithms. So if we go into the subset analysis, artificial intelligence overall is a program that can sense, reason, act, and adapt. When we add machine learning to it, we get algorithms whose performance improve as they are exposed to more data over time. And deep learning is a subset of machine learning in which multi-layered neural networks learn from vast amounts of data. Sorry. So this is a cartoon about machine learning and deep learning. The applications of machine learning and device therapy for heart failure are increased patient engagement, and we get digital health integration, improved prognostic modeling, and we get early detection of at-risk population, enhanced perioperative workflow, and we get perioperative medical optimization, and risk stratification and phenotyping, wherein we get individual patient models, personalized medicine can be delivered. And the example of deep learning is when we put in lots of data out of the records, we can get risk of 1 year decompensation, we can get when patient can worsen, and we can call the patient for those type of visits even early. Again, very technical aspects, but are integral. I can try to make it easy. These are neural networks. So a neural network makes mistakes and it learns from them. So machine has data, machine has patient data, machine has doctor's feedback. It may create an error, but when as a human being I tell that this is the error you have made, for future it will correct itself, and that is the role of artificial intelligence. Then there are convolutional neural networks, that is CNNs excel in image-related tasks. As we discussed about a case of amyloidosis, future of MRIs, X-rays, everything, you just need to put up that particular patient's X-ray into the machine and you will get diagnosis automatically. And recurrent neural networks, so RNNs are effective for sequential data analysis. So once we have fed all latest data about the patients, we have created a database and we apply RNN networks, we can get guidelines out of it. Automatically we put that when patient should be called, we put what should be done for diuretic therapy, and we can get guidelines by the use of artificial intelligence. The clinical applications, up till now what we discussed was machine learning, theoretical, technical. As clinicians, we want to know that what it will do. So definitely diagnosis by imaging, echocardiography, ECG and MRI will become easy. Monitoring devices will be available, wearable devices will be available, AI-enabled platforms, Internet of Things, natural language processing, and telemedicine and mobile health. So in terms of telemedicine and mobile health, it is possible to tailor personalized treatment planning, correct drug dosing, and identify patients at risk for adverse events and readmissions. Veta Health is an example of an AI-powered telemedicine platform which is available even today. Wellbe, again, another remote monitoring platform. So various platforms are available. We only need to bring them to our practice. Monitoring devices, wearable devices that continuously monitor heart rhythm and are already used for detecting fibrillation are a Cardia Mobile by AliveCore and iRhythm Zio by XT. Even Apple Watch is an example of a wearable device. So various other modalities are there which can predict volume overload, which can predict that the drug interaction is happening or some drug adverse events have happened. Internet of Things is a difficult concept, but basically use of electronic sensors embedded in objects that are regularly part of our environment by means of a common software platform. So for example, you have a Gita bed or a Janak bed, and it is embedded with 10 sensors from head to toe. And those sensors can give you heart rate, BP, SpO2, and respiratory rate, whatever we monitor, except for intra-arterial. And that will be available via Bluetooth on a mobile. And for example, Jani sir is the owner of a 10-bedded ICU, and he is going to take care of 4 beds. I am going to take care of 2 beds. And Madhu madam is going to, like, we have distributed beds. Kamaldeep ka patient ye bed pe aayega, iska patient ye bed pe aayega. So my patient's data will come to me, and his patient's data will go to him. This is what is the concept of Internet of Things. Natural language processing is concerned with giving computers the ability to understand text and spoken words in much the same way that human beings begin. So it is like Alexa of things. So Alexa, how is my patient at bed number 4? And then we'll get back the answer. I'll not go into details of imaging because I think I've already explained that. Smart clinics is something emerging, and I think most of us will have to gear up to adapt to these clinics. So medical institutions that create new value and insights on patient safety, quality of care, and cost effectiveness using information and communications. It basically encompasses Internet of Things, mobile health, AI, robotics, high-speed communication networks, and telehealth. And it will be one platform to manage your patients and your clinics. Challenges and considerations for the use of AI are data privacy, interoperability, and regulatory compliances, clinician education and training, and continuous validation and refinement of algorithms. So it's easy to talk, it's easy to get the gist of things, but difficult to maintain. But I think there will be solutions for that. To summarize, AI tools encompass a range of technologies designed to predict, monitor, and manage heart failure patients more effectively. Advanced learning algorithms, including machine learning and deep learning, to analyze various data sources such as medical imaging, wearable devices, and implanted sensors. AI tools for heart failure aim to improve patient outcomes by facilitating early intervention, personalized treatment strategies, and better management of heart failure patients. They also hold immense potential to revolutionize heart failure care by providing cardiologists with advanced predictive analytics, imaging, and various treatment optimization strategies. However, a collaborative effort between clinicians, researchers, and technology developers are key to harness the full benefits of artificial tools in a heart failure management. The future perspectives are multiple applications like health risk assessment, continuous monitoring of health status, smart interactive planning, early recognition of red flags announcing acute complications, and prediction of likelihood of responding to a particular treatment. So that particular patient, by parameters, for example, pro-BNP values, whether to give Lasix, whether to give diet, or whether to give Zytonix, we can have predictive answers. It's very important to get from shifting from research models to specific health issues. Truly personalized interventions and triggering early interventions is the future. And they'll be very helpful to support the discovery and development of new therapies for heart failure, improving our understanding of underlying mechanisms. They'll be very important in phase 1, phase 2 clinical trials also, wherein the drugs are being tested. So this is the cartoon to understand the pros and negatives of artificial intelligence. So AI was asked to make a picture of Mother Teresa fighting poverty. A beautiful picture. She's fighting poverty, but the saddest part is that AI still thinks that blacks are poverty. I mean, this is very unfortunate part, and I think in the future that will be corrected. And I would like to end my talk with this Avatar project milestone, which is going on. So by 2040, we'll have a hologram like Avatar. So we still have few holograms, 3D holograms we have. Modi ji delivering his talks. Avatar C 2030 to 2035, AI with an avatar with artificial brain in which human personality is transferred at the end of life. So I wish my Nani, on whose name we are having an oration today, so we had her along with us, something like that. So ultimate aim is that human thoughts and human brains never stop, and it's an ongoing process. Thank you.